Hello. So I guess we're starting a little bit late, but let's get started. So I'm going to talk a little bit today about building resilience in operations and development. And my experience is on the web. I do want to ask, how many people here work in a website? Okay. Excellent, excellent. Even if you don't work on a website, I think that building resilience in whatever information technology domain you're in, I think will apply. And we're going to keep it high level. So first of all, a quick introduction. As I work at Etsy.com, we're building the world's handmade marketplace, where we connect buyers with makers of things and sellers of things, people who feel passionately about what they make. So in some quick context here, these statistics are for May of this year. We sold about $40 million worth of things on the site. A little over 2 million things were sold. 2 million new things were uploaded to the site for sale. And there were about 400,000 new members and 1 billion page views. I thought this photo was really great. This is a paper cutout of Paris, a map of Paris, which is very, very cool, I thought. One thing that we're not going to talk about a lot today is the technology stack that we use. It's relatively boring. We use some pretty mature technologies. We use PHP and MySQL and Postgres and Memcache and Lucene for searching. We don't want to innovate on the technology that we have. We want to innovate with the product that we have. So we have these three things. If you work on a website, these are challenges. These are the goals that everybody likely has, right? So we need to keep it fast. We need to make sure that the site is very fast. We need to make sure that the site is up and available. And we also want to be able to change it whenever we want to, and it be okay. For those of you who have worked on websites, or actually in any technology, how many here who have been involved with fixing things after they've been broken? Okay. How many of those people who had to fix things when they were broken, it broke because somebody changed something? All right. I think I see more hands the second time than the first time. Okay, so lucky for you, Jez Humble is going to talk a lot about that a little bit later. But it is still the point still stands that this sort of stuff costs money. And if you don't keep it fast, your business is going to lose money. If you don't keep it up, business is going to lose money. And if you can't change it as fast as you can, the business is going to lose money. Some sort of baseline here. Websites are complex and dynamic systems. They are not simple machines. They're not like a seesaw or a swing at the playground. Okay? What I mean by complex and dynamic, I mean in opposition to the Cartesian thought of we have a bunch of components, and if we break the components into, we break the system into little components, and we understand each component, then we can understand the whole thing. It doesn't work like that. These are complex systems, which means unexpected, fundamental surprises can happen out of nowhere. Stuff we couldn't predict. That's why things break. The approach that I'm saying when I say resilience is, and the approach that we take at Etsy, can be viewed in this sort of lens. Okay, on the left we have a Jeep. Okay, this is a vehicle that's built to be repaired. Its designers know you're gonna beat the hell out of it. Okay, there's a reason why it started in the military. There's an excellent video on YouTube of a military group completely disassembling a Jeep and reassembling it within 2 minutes. Okay, the designers had this idea: we need to build a resilient vehicle. On the right-hand side, I believe is Rolls-Royce. It is optimized for mean time between failures. If you buy a disk drive, on the side it says, 10,000 hours between failures. It's optimized to just not break. You don't want it to break. Now, it doesn't say anything about how long it's going to take to repair it. It's likely if this thing breaks, it's going to be in the shop for a long time, and it's going to be really expensive, right? It's a flip of perspective. This acronym, mean time to repair, or mean time to recover, or mean time to resolve, is what we're after when we say about resilience. The side effect of building a resilient system is that you have confidence. You have confidence in the people who are putting it together. It's not that developers are having confidence, but operations people have confidence. Support people have confidence. The community of your website has confidence in you because you can fix things very quickly. And the product people have confidence. Resilience engineering in and of itself is a study that doesn't even have anything to do with websites. It comes out of human factors and safety engineering, and there's a couple of decades of research at this point. But loosely defined, resilience is the intrinsic ability of a system to adjust its functioning before, during, or after. Right? The idea that you can fail fast and recover quickly. We want to be resilient because these unexpected outages can happen. For the rest of the talk, I'm going to be ripping off everybody here. These guys are some of the most forward-looking researchers on this topic, and they apply these principles to everything from aviation to manufacturing to nuclear power. Excellent stuff, and I'm sure their slides will be around, but I would encourage you to, if you're interested at all, into reading any books that these guys talk about. So, when we say the system, I want to be clear, we're not just talking about the code, the servers, the networks, all of that. We're also talking about the humans that operate it. When things go well, it's because of humans. When things go wrong, it's likely because of humans. It's easy as engineers to forget this part. It's easy to forget about these people because we want to think that we can manipulate our destiny, right? And talking about people and how we get along and how we can interact, especially during stressful situations, is a bummer. So there's these 4 cornerstones. Eric Holdengel, I think, made an excellent lens for talking about these things. The 4 cornerstones of resilience engineering. Anticipation, monitoring, response, and learning. That's how we're going to sort of structure this sort of thing. So the first is anticipation. This is really getting an answer to the question, what could possibly go wrong? Prioritizing this question. Having developers and operations people and product people and support people spending time thinking about the answers to these questions. A good friend of mine, Artur Bergman, once said on Twitter that a pre-mortem is better than a post-mortem. This is what anticipation is all about. So what are some of the things that we do at Etsy? One thing is that we have architectural reviews. If there's a departure from a way that we have been doing things in the past, if we're using a new technology, we have a review. It's just an informal meeting, and anybody can come and ask questions, and somebody says, oh, I want to do it this way, and it's different, and I have to do it differently than the way we used to do it because of this, this, and this, and this. And the rest of the company just tries to poke holes in why that needs to be different. Because having things special or different in a complex system introduces new variables. The go or no-go meeting. Before we launch any public feature to the live, at least that's significant, we get 10 minutes, people in a room from all parts of the company, and they get to say go or no-go. This means that people need to think about contingency planning. They need to think, what is the thing that could possibly go wrong? And is it going to affect what my responsibility is to the business? Game day exercises. This is testing in production failures. We will periodically I'll call up somebody at the data center, and I will say, you see that server over there that's next to the rack, over the one with the power light on? Yeah. Pull the cable. I told the CEO at Etsy within 2 years that I don't think that I'm doing my job if I can't walk him into the data center where all the servers are, and he can pull any 5 cables he wants, and the site should still stay up. So there are some anticipation patterns which can help sort of illuminate some of these things. I got these from Dr. David Woods. He's one of those guys that were on the slides. Recognize when adaptive capacity is failing. This is pattern number 1. Having the ability to think, oh, the code is stretched beyond its limits. The infrastructure is starting to, our ability to change the code, the infrastructure, our process, our organization, is starting to wear thin. Okay, this could be the infrastructure's capacity to be agile in its ability to absorb unexpected changes. It could also be on staff level, right? If anybody's been a part of a website outage that's gone on for a long time, you know the ones that you read about. If Google is down, if Facebook is down, if Amazon is down, these are the things you read about because they go on for so long. People can get stressed during those times. We're going to talk a little bit about that. Better number 2 is to recognize the threat of exhausting buffers or reserves, right? There's a safety factor that's known throughout all of engineering, hopefully, at least in bridges and airplanes. Having a safety factor means that you have some wiggle room, okay? You have some wiggle room to take on more load than you expected. Better number 3 is to recognize when to shift priorities against goal trade-offs. What this means is, what would you rather? There's a great story actually out there that I'll tell. My boss, Chad Dickerson, worked at a company called CNN. You may have heard of it. They had, I can't remember, in the 90s there was a U.S. presidential election, and they were putting the election results on the site, and as in real time, as close to real time as you can. There was so much traffic that they couldn't log to the servers. They could, if they stopped logging, they could serve the traffic. But the logs included the ad impressions. So they weren't going to be paid for the most trafficked hours of their entire career. This is what I mean by recognize when to shift goal trade-offs. The short story is they turned off logging. The site stayed up. Better number 4 is navigate interdependencies between different roles. You're a developer, you write code. You're an ops guy, you build the servers. You're customer support, you handle inquiries that come in, right? When things go wrong, sometimes the guy that writes the code has to deal with the servers because that guy's really busy. And the guy that builds the servers have to handle inquiries coming in. So being able to cross, to get out of your familiar roles is something that anticipation can do. And this is what's kind of known as DevOps, at least part of it anyway. And recognizing the need to learn, right? We're going to talk a little bit about that in the learning phase. But this is what happens when you have postmortem meetings. So we've talked about anticipation. The idea here is that this anticipation gets to inform, hey, we think this might go wrong. Maybe we should monitor this thing. It might go wrong. We should watch it, right? Maybe we should, after something does go wrong, we should look back. Did it actually go wrong, right? We should let what we come up with for anticipation inform the rest of them. So now let's talk about monitoring. So the first thing that I can't say more, I can't say too often, I can't say to too many people, is that metrics are part of your product. I don't care whether it's your website, or if you work in an enterprise or you make software, if you don't have the ability to measure whether it's doing well, whether it's doing what you expect, then you're doing it wrong. It needs to be part. Metrics and graphs and all of that logging, all of that stuff shouldn't be an added-on thing. It's supposed to be thought of before you even finish the product. Because otherwise you won't have any idea whether it's any good or not. You made a guess about it. So then your ability to adapt to these unexpected changes, failures, degradations, there's the data. You have data there. So, of course, everybody here hopefully should have metrics about infrastructure, servers and CPU. Does this look familiar to anybody? CPU, network, disk, right? Servers do things. When you work on a website, we have a global audience. Okay, having some context. Because of the speed of light, and it's the thing where you can't go faster, the internet can make things slow for people, right? This is a graph of failures, and it just so happens that South Africa, I took this screenshot, that South Africa had a really hard time getting to Etsy, and now we can see this. It wasn't just that there were issues from, Australia. It was just localized to this region. Now we have a context of things going wrong that's specific to a region. Another example is having all of your business metrics. This should actually be the first slide, actually. This is a graph. We use an open source graphing tool called Graphite. It's excellent. You should try it. This is the number of registrations on a 24-hour period, the number of times people are logged in, the number of errors, the number of, that orange are things being bought on Etsy at any given moment. This is the graph of the new listings that sellers are uploading, and a couple of other things. This thing over here on the right is the number of posts per minute to our public forum. So when you see it spike, it means that maybe something's up or something's weird because people are talking about it. The other thing that we bring to metrics is this event awareness. Okay, when I said when all the hands went up about people who make changes, sometimes unexpected results can happen, and we draw vertical lines. Right, when we deploy code to production, we draw vertical lines on all of these things, so we can correlate. Okay, we pushed a bug. Okay, well, what did that do to sales? What did that do to registrations? What did that do to logins? Okay, maybe people can't log in. Maybe the people who can log in can buy things, so that's good, but new people can't log in, so that's bad. Now, if we didn't have this situational awareness, we wouldn't be able to discern one failure from another. We use Internet Relay Chat, or IRC, at work, and this helps greatly, especially when there are outages or failures, right? This is essentially a log. It's chat. Okay, everybody at Etsy uses it, and the greatest part about it is that we log it. We actually stick it into a search engine so we can see if somebody had said something else in the past. Maybe we've seen this problem before. And the best part is we get this timeline, right? Here's what people said when. And sometimes people will point to a graph. They'll put in a URL and say, hey, take a look at this. There's something wrong. Or I don't understand this graph. And so now we can get the full context of what people are talking about. The result of this is it looks a lot like a flight data recorder, right? The black box that are in airplanes that records everything that goes on, and you got to go to the bottom of the ocean and pull that up, but it's got everything there. The other thing about metrics and monitoring is that at least at Etsy and a lot of other successful companies, that we aim to get full stack metrics. What this means is we've got somebody on the internet making a browser connection, and they come through networks, they come through routers and switches, and they get to load balancers, and then they get to servers, and then there's databases and all this sort of thing. We want to be able to drill a hole, shoot a bullet straight all the way through. We want to be able to, when somebody says, I bought something on Etsy, I want to be able to point to logs and say, or point at a graph and say, oh, here's you. That's you right here. Because if something went wrong, I want to be able to explain it. Right? They made the amount of effort to come to our website to buy something. The least we should do is be able to tell them what went wrong if something did go wrong. So this involves a human, right? This is that we have to remember that people use websites. This is my friend Micah, and she has a daughter Nina. She goes looking for a onesie on Etsy. Right? We want to be able to tell her what happened during that whole time. Right? We want to have answers to these questions. Did she find the onesie? Right? How long did it take her? Did she buy it when she found it? How much CPU did the web servers expend for Micah finding a onesie? Right? If there are all kinds of people searching for onesies at once, does it get slower or does it not matter? How fast were her requests? Were any of them slow? Did she get any errors during her whole time searching for this piece of clothing for her baby? Did she get so many errors that she's never going to come back? This is what we talk about when monitoring, which is knowing what to look for if things do go wrong. So we've talked about monitoring. Let's talk about response. This is my favorite part. Like I said, we want to detect things fast. We want to recover fast. We want to have the tools available. We want to be prepared. We want to have, metaphorically, we want to have the drills and the screwdrivers and the hammers and the nail guns and the lasers, whatever we need to do to fix things. We want to have them on hand. We want to be trained to use them. One of the things that we have is feature flags, or Jez might call them feature toggles. We've got, at the moment, a little over 600 different pieces of functionality on Etsy that we can turn off at any given moment. And when you go to a product guy or the CEO of the company and say, I got a question for you. If something goes wrong, which would you rather have? the site go down or the ability for users to not chat with each other? Okay, so he's going to pick this one. If you don't have that ability to turn things on or off, then you don't have many options, right? If it's either the site's up or the site's down, it all works perfectly, or it doesn't work at all. This means you don't have what we call graceful degradation. This is actually cut and paste from one of our files. It turns the ability to favorite things or to like things on Etsy and be able to view those things. We can turn them on and off at any moment. So let's walk through some crisis patterns. This hopefully will look familiar to you. Something happens, a problem starts. You detected that something happened. You see, well, should we work on this? Okay, well, we should probably fix this. We fix it. We do some troubleshooting. Then we say, okay, does it look okay? It looks okay. We ask everybody, is it okay? This looks good. Or let's call it all done. Okay, now it's all clear. Okay, great. So when a website breaks, you can almost guarantee, this looks pretty simple. This is sort of a timeline. This is what happens. But the people working on it are pretty stressed out. This is probably what they feel like when things are going wrong. Remember, on a website, it's like 24/7 live TV. It's always on, no matter what time zone you're in. Let's take another look. Detecting something went wrong, evaluating whether things went wrong, responding, and all of that. This is kind of a bummer. Because what this means is that it took you a long time to even know that something went wrong. There's probably a gap in your monitoring. And maybe the thing was really easy to fix, but you just didn't know it. This is really embarrassing. So your friend calls you on the phone. What's going on with your website? Something's broken. The CEO's wife calls and says, I'm trying to buy something. This is a big bummer. You had no idea. A little demoralizing. And the stress goes like this. It's mostly full of embarrassment because you didn't know. Right, and you could fix it really quick. And then here's actually my true favorite. This is why I'm in this business. If you have a response scenario that looks like this, it's likely because it was hard. What happens here when there's a long response time, it means that you have got a team of people working on it. Right? When a website's down for a couple of days, the ones that find stories in the newspaper or the magazines, it's because this was a difficult problem and a number of people were working on it. What happens here can infuriate and mystify and energize an entire engineering organization, and you can be absolutely assured that no matter what the outcome is, there's mental scar tissue that's going to affect how the people who worked on this problem how they are going to behave in the next 10 years. So my point here is paying attention to how all of these things go is part of becoming resilient. If you ignore them, these are stressful scenarios. If you ignore them, you're likely to repeat them and be frustrated again. The one quick note about response is this role of improvisation. I believe that it's absolutely a requirement. We need to accept that improvisation is part of correct and good responding. We need to train people for improvising. We need to expect that this is going to happen. I'll give you two examples. 1970, Apollo 13, 250,000 miles away from the Earth. Oxygen goes away. There's 3 guys in a space capsule. Okay, if anybody's seen the movie, a bunch of NASA engineers are put into a room and said, here are all the things that you can only find in the capsule, including duct tape and a bunch of filters and a couple of hoses. And they improvised, and they managed to get those 3 guys. This is NASA, the same people who put people on the moon. They are really smart guys, and there is no procedure on how to do this. They improvise and put it together. Here's another example. Chesley Sullenberger, 90 seconds after taking off from JFK, geese went into the engines of his airplane, completely exploded the engines, and he had to improvise. So that was 30 seconds after he took off. Another 60 seconds later, he had landed the plane on the Hudson River. Okay, there's no procedure. This is what people's adaptive capacities and an engineering level can do. So as it turns out, humans are pretty important. So we should pay attention to them. So we're talking about the response, and now we're on the last piece here, which is learning. There's two pieces that I want to talk about here. And of course, all of these cornerstones could be the topic of talks that go on for 8 hours. Okay, this is sort of the high-level overview. Things that we find very helpful at Etsy are near misses, communicating near misses, and postmortem investigations. We see a lot of emails that look like this. When somebody almost, the equivalent of almost turning in the wrong way down a one-way street, and forgot about that, shouldn't have done that. When you have a culture that has enough humility to admit that they almost did something super dumb and want to improve everybody else's ability to avoid that, including standing up and saying, I almost did this, I almost lit the house on fire, I almost took the website down. I'm going to, don't do what I did, first of all, and I'm going to change something so that nobody else can make the same mistake that I did. This is a very good indicator that you're doing a pretty good job. So that leads us to postmortems. Postmortems are when the incident's over, and now you have to look back. Okay, in 2008, I wrote a book called The Art of Capacity Planning. That book was about predicting the future. Okay, postmortems are about telling the past, which, as it turns out, I think is way harder than telling the future. The basics. Who here has ever been part of a postmortem meeting? Okay, cool. It's where a bunch of really probably stressed out people gather in a room, write down what they think happened, and come up with ways to prevent it from happening in the future. So you want to have some basics, right? You want to know when it started. You want to know when you found out that it started. You want to find out how long it took you to recover from it. All of these sorts of things. You also want to find out about severity, right? Not all outages are created equal. Having to lose the website being down versus, members of the community can't post to the forums are two very, very different things. And each company is going to have to define these things for themselves. My recommendation is to keep them very high level and keep them granular. You want to be able to at least communicate how awful the event was. So now this is what you've got. You have a meeting. Oh, you get some people who disagree. Oh, no, wait, this happened before this happened. Okay, well, you get it all. You get a timeline. It's all constructed. Okay, so this is the how. How did it happen? The one thing that I will point out is that people in stressful scenarios will misremember how things took place, and especially on a timeline. Anybody who's ever been in a traumatic accident or a traumatic website outage will understand this. This is why when I pointed to having IRC with a timeline on it's very important, because in retrospect, things tend to feel different. Things are misremembered. So the idea of postmortems is to work out how, and that's your timeline. If you establish the facts, you of course want to get to an idea of why, okay? And then you want to figure out what to do to prevent them. I'm not going to talk about this too much, but one thing, who's heard the term root cause analysis? Okay, so the root cause analysis greatly influenced by our reductionist thinking. Complex systems always have multiple contributors. You may think that there is a root cause, a single root cause. I'm here to tell you that there isn't. There is never, ever a single root cause. They are multiple contributors, only jointly sufficient to cause an outage or a degradation or a failure, an unexpected, a fundamental surprise in a complex system. Finding a root cause is, if you're looking for a root cause, you will find it. Okay? Expecting that accidents happen due to a linear causality you can absolutely write that. It's affected by hindsight bias. Looking back on which is a psychological phenomenon that complex outages seem to look much more simple in the past, right? Oh, I should have seen that. Well, you didn't. If you had seen it, then it wouldn't have happened. I could go on and on about this, but like I said, it's beyond the scope of this talk. But root cause analysis is working out why it did happen, gathering all of the pieces and trying to put them together. And then, of course, there's the human part, okay? Some of those multiple contributors might have been a change that someone made, okay? The idea of having a postmortem where blame and possibly shaming is part of the process is a very, very losing proposition. They should not be, they should be blameless. You can still have accountability for people without having blame. You, Jez Humble, you screwed it up. That's why the website broke. You made the change. Should have known better, willful violation, gross misconduct, unacceptable behavior, right? Don't do that, right? That follows the theory of the bad apple. It's not the thing that they did, it's the person who did it, right? That doesn't actually work, okay? Penalizing people for making changes that result in unexpected or unwanted or negative outcomes, it only teaches your organization to not give details about when it happens in the future. Empowering people when they do make a mistake or when they do make a change that resulted in an outage is the better way of going about things. That way, it's not who is responsible for this problem. It is what is responsible for this problem. There's at least 4 books by Professor Sidney Dekker that goes into this idea of having a just culture in your organization, no matter whether it's a website or not. So, we've now talked a little bit about learning. What are some of the takeaways? There's about 30 minutes. So, building resiliency in this context, you could say, focuses at least a bit at the high level on these questions. What could possibly go wrong? How will we know that they're actually going wrong? What will we do when they do go wrong? And how can we learn from our failures? Okay. But also, and this is a challenge to the people in our industry to think about things a little bit differently. Think about it in terms of these questions. What could possibly go right? For every time something goes wrong, there are many, many, many more times when they go right, but yet nobody looks at those. Safety isn't the absence of failures. It's the presence of something that mitigates failures. Okay? How will we know when things are actually going right? What will we do when they do go right? And instead of learning from our failures, how can we learn from our successes? So, don't take past successes as a guarantee of future safety. Your organization, in order to be resilient, needs to have a constant sense of unease. Metrics and graphs are everyone's responsibility. I don't care whether you build the servers or you write the code. If you're not interested in how it's doing, you probably shouldn't work there. Graceful degradation options should be considered mandatory. Okay? Planes, boats, they can all absorb failures. It doesn't have to be on or off. Non-technical teams, support, PR, finance, they need to be involved in this process as well because they are part of your organization and they need to be part of contingency planning. Fear of punishment cannot get in the way of learning. And if you build an organization where punishment, firing people, docking their pay as a result of actions that resulted in outages, you're going to get a very uneducated organization. And the final piece is that, especially towards the DevOps topic, is that you can't hold people accountable if they don't have both the responsibility for things like performance and availability, and the requisite authority to influence those things. which means that as leaders in the field and as management, you need to give people enough authority to affect what they are being held accountable for. So I hope some of that makes sense, and I think we have maybe a couple of minutes for questions. I'm not sure. Do you have questions?
Hi. Can you hear me?
Yes, I can.
All right. You talked a lot about metrics.
Uh-huh.
Capturing metrics is data intensive. How do you make sense of all those metrics, all those data? How do you visualize them, and how do you make them speak to you?
Yeah. So that's a really good question. So the question was about metrics. At Etsy, we believe that every developer should be able to make a metric, even if operations owns the infrastructure that collects and displays the metrics. Developers should be able to create a dashboard for anything. Right? What you end up with, though, is once you give the people power to do it, they will make graphs. And now there's 160,000 metrics just at Etsy across the entire board. Being able to build dashboards at Etsy, we actually have 6 massive plasma screens. And it's just a little tip of the iceberg in the office. There's many, many, many internal web pages that have all of those sorts of things. Being able to bubble up which ones are important is a challenge, right? It's a good problem to have because at least you have the data. But involving the people who write the feature to also influence thresholds of warnings and critical alerts that would trigger off of those is also important. I don't believe that operations, that ops or systems administrators should be the only ones who look at or can build or anything like that. Graphs and metrics collection systems that have password protection on them, that's what I think. Anybody, the CFO should be able to look at what a server's doing. There's no reason why anybody should be protected from seeing those things. But organizing which ones are most important is a challenge. Making the business metrics, like I said, the number of checkouts, the sales registrations, putting those up front and overlaying things on top of that, or at least putting them aside of them, is a good way to remind people what's actually important to the business.